So the next question is, how do we find the angle alpha? Alpha is found from the trigonometric ratio tan alpha. Tan alpha is equal to height upon base, and that comes to be equal to this b sine theta upon a plus b cos theta, which you can work out for yourself. Now the second analytical method which I mentioned before, is the parallelogram law of vector addition, which states that if you have two vectors a and b which are to be added, instead of representing them along two sides of a triangle, we represent them along two adjacent sides of a parallelogram. Such that if I complete the parallelogram, then the longer diagonal represents the vector sum, such that length of the longer diagonal is equal to this, it comes to the same, and tan alpha, which gives the direction of the resultant, comes out to be this. Now, there are some special cases out here. When I have the two vectors which I am adding, if the angle theta is 0 between the two vectors, that means A and B are along the same line parallel to each other. Now when A and B are along the same line parallel to each other, then from here R becomes equal to A plus B. Length of R is length of A plus length of B. It becomes exactly like scalar addition. So vector addition becomes similar to scalar addition, provided that the two vectors are along the same line parallel to each other. And then the angle alpha is 0, so the resultant vector R becomes parallel to A, and length of R is length of A plus length of B, and this is what it looks like. Now suppose the angle between the two vectors is 90. So they look like this, or they can be made to look like this, triangle. And then we find from here that once I apply this, cos 90, R is equal to this. It's exactly like a right angle triangle. R square is A square plus B square. And tan alpha is B upon A. And please do not assume that alpha has to be 45 degree. Alpha is 45 degree only if the length of A and length of B are equal. And the third case is, say theta is 180 degree. The two vectors are anti-parallel to each other. Then we have R is equal to this cos 180 over here. So R will be A minus B or B minus A. Now when will it be A minus B? R will be A minus B when length of A is greater than B. When will it be B minus A? When length of B is greater than length of A. And depending on that, if length of A is greater than length of B, R will be in the direction of A. And if length of B is greater than length of A, R will be in the direction of the greater vector B. So this is what we have about vector addition. Now a very, very interesting thing about vector addition is that the order of adding the two vectors is not important. So if I add vector A first with vector B, this is the resultant vector that I get. And if I add, instead of that, if I first add vector B and then the vector A, I get exactly the same resultant. The start and the finish point are exactly the same. So we come to the conclusion that vector A plus vector B is the same as vector B plus vector A. This is a law which we call commutative law for vector addition. Now there's another law. If there are three vectors, A, B and C, which I have to add. So let's say this is the vector A, this is the vector B, and this is the vector C. I first add A and B and I get this vector. And then I add the vector C and I get this is the resultant vector. Now instead of doing that, what if I first add vectors B and C? This is my resultant, B plus C. And then I add A with B plus C and I get exactly the same resultant. So I say A plus B added to C is equal to A plus B plus C. So I put this in bracket indicating this addition I've done first here, and I put this in bracket indicating that I have done this addition first. This is another law called associative law. So we say vector addition obeys two laws. One is commutative law, the other is associative law for vector addition.